to another session of Concept at Fingertips. This is Vidya, physics faculty from Acharya coaching. So today let us see the topic parallel combination of resistances. So in a previous video, we saw about the series combination. So in series combination, we saw that the total resistance or the equivalent resistance of a series circuit will be the sum of all the resistances. And in that way, it will be greater than any one of the resistance in the circuit. So if you want to increase the resistance in the circuit, then we can go for series combination. But parallel combination will have a different property. So we will see parallel combination in today's session. So here we have a circuit given, and this is a circuit from NCERT textbook. Here we have three resistances R1, R2, and R3 connected in parallel. And we have a voltmeter connected across them. And we have a supply which consists of 4 cells connected in series. And we have a key and also an ammeter to measure the total current. So a total current I is given in the circuit, and we have X and Y terminals across which this voltmeter is connected. So let us analyze the resistance in the circuit. So here we can, what we can see is this current I, when it reach here, it's going to split into 3 currents. So it is going to split into 3 currents, and let's represent the current as I1 in the first resistor, I2 through the second resistor, and I3 through this branch, that is the third resistor. So we can see that the total current I is getting divided into I1, I2, and I3. So I1 plus I2 plus I3 will be the total current I. So if we can convert this circuit into an equivalent resistance, these 3 resistances into an equivalent resistance R equivalent, and we can draw the supply as the same supply. And this is the total current I. And if we measure the voltage across this equivalent resistance, it will be V. So if you are applying Ohm's law in this equivalent circuit, we'll get V is equal to I into R equivalent, or I is equal to capital I, or the total current I, which is same as this I, is equal to V by R equivalent. So substituting it in this equation, we can say V by R equivalent equal to I1 plus I2 plus I3. Again, let us see what is I1. I1 is the current flowing through the R1 resistance. If you apply Ohm's law in this branch alone, we can say I1 is equal to V by R1. Here, the voltage, the potential difference across the 3 resistances which are in parallel combination, it is the same. So the potential difference across each resistor in parallel combination will be same. In the same way, what is I2? I2 is equal to V by R2. I3 is equal to V by R3. Now we can write these values in this equation. So V by R equivalent is equal to V by R1 plus V by R2 plus V by R3. So we'll rewrite it in the bottom like V by R equivalent equal to V by R1 plus V by R2 plus V by R3. Now taking V common, we can write V by R equivalent is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So we can cancel this V on both sides. And we can say 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the relation for equivalent resistance in a parallel combination. So to summarize, we can write in a parallel combination, the reciprocal of equivalent resistance will be equal to sum of reciprocals of individual resistances. So this is the peculiarity of the parallel combination. The another main feature of the parallel combination is that the equivalent resistance of the parallel combination will be less than any of the individual resistances. So let us say one example. We have R1 is equal to 2 ohms and R2 is equal to 4 ohms. So these are the two resistances and we connect it in parallel. So let's say this is R1 and this is R2. R1 is equal to 2 ohms and R2 is equal to 4 ohms. So this circuit can be drawn as an equivalent resistance R equivalent. So we'll find it out. One by R equivalent is equal to 1 by 2 plus 1 by 4. Taking an LCM, we'll get 4 in the bottom and you have 2 plus 3. Sorry about that. 2 plus 1. So we'll erase this portion and we're going to continue from the top. Okay, so let's write it here. So 1 by R equivalent is equal to 3 by 4, or R equivalent is equal to reciprocal of that, right? 4 by 3 ohms, which is nothing but 4 by 3. 1.33 and so on. So this 1.33, let's take it as 1.33, approximately 1.33 ohms. So if you consider this R equivalent and if you compare it with this 2 ohms and 4 ohms, we can see that the equivalent resistance is less than even the smallest resistance in the circuit. So if we want to reduce the resistance in a circuit, we can use a parallel combination. So what are the main points in the parallel circuit? The current through individual branches will be different, but the potential difference across all these resistances will be same. And reciprocal of the total resistance or equivalent resistance will be equal to reciprocals of individual resistances. I hope the topic is clear to you. We'll meet you in another session with a new topic. Thank you.